So our goal today is we're going to do exactly what we did yesterday. We're going to try to evaluate limits. Yesterday, I called it the GNA approach, but we did the G, which is graphical. That's not so hard. Like to read a graph and determine the limit, you just come in and where you are on the y-axis is your limit. So the graph's easy to see, but you'll be tested on that on the AP exam and on mine, but almost everyone's going to get that right because if you understand them, if you see the graph, it's pretty easy. The table is a little more wishy-washy, so you won't see a whole lot of tables. It's not a really concrete way to get a limit. The most common way is to do it analytically, which is what we're going to do today. The reason the notes take so long is there's so many different approaches you can take, so I have to kind of get through all of them. One of the approaches you did in pre-calc, but the other ones you didn't. So, and what happens when we do it with algebra or analytically is we lose the visual, so you lose track of what you're finding. So if a question gets worded differently than what you're used to, sorry, I'm trying to, you won't know how to answer it because you won't be seeing the graph. Before we start though, I want you to, at the bottom of one of your pages, we're going to sketch a graph. All right, I kind of think that you might want to write this down, so I'm going to give you a couple minutes. There's a star by this. What the stars are going to mean in your notes is that I'm going to put a very similar one on your test. I do that for this first chapter, so you know how to prepare for a calculus test. I remove those immediately. It's only chapter 1, but I do get you to interact with your notes and see that things we do end up on tests. So I would put a little star by that, because in order for you to do a test fix for chapter 1, one of the criteria is going to be that you've rewritten all the starred problems in your notes. You've interacted with them, the ones I'm saying for sure I'm testing you on, before I test you, not after. Okay, so put a little star by it. Anytime I star something, it means we're doing, and there's going to be several stars today. So this is a big day as far as test material. I might make up to 5 stars. So 5 stars upon stars. So go ahead and just blindly copy that. I'll wait till somebody up here is done, and then the rest of you can kind of catch up as we do it. I'm on a time crunch. I have to get to where we got first hour. Or they'll have to re-listen to something they already did. I shall have you on your test sketch a graph that meets certain criteria. It'll be different criteria, obviously. I wouldn't have you make the exact same graph, but I want to make sure you learn how. There were 2 of these on your assignment too, weren't there? But it only had 3 criteria. So I'm kind of taking those off your assignment and upping the ante a little bit. All right, if I didn't give you enough time, but I just saw Andrew finished, and I just pick it up when we get there. Don't keep writing, just like when we get to I'll do enough talking where you'll be able to fill in the last couple. So when you read one of these problems, you can't do number 1, then 2, then 3, then 4, then 5, then 6. You can do little things so that when you're done, it's all pieced together, but I wouldn't immediately go draw a function that has that domain because there's other criteria. But I'd analyze what this means. When this is closed, it means I must stop at 0 solid dot there, done, right? When this is open, it means one of 2 things. What's one of the things? It could possibly be. It could go to infinity. I could have an asymptote there. I'll need to read on to see, right? Or what could be there if there's a wimpy bracket? A hole or an open dot. If there's nothing to definitively decide through the other lists of criteria, then I can pick. Does that make sense? So there's actually something on here that tells me which it's going to be. Which number tells me whether I'm going to have an open hole there or an asymptote. I'm talking about at 5 where it's open. There's a criteria up there that tells me. Which number is it, Jordan? Number 5 seals the deal. I'm going to have an asymptote there. Agreed? And I will be heading up. at 5. So I'm going to go put it on there. 1, 2, 3, 4, 5. So notice I'm not really reading them in order. I'm going to make sure that I hit an asymptote there, and I'm going to make sure I go up, and so that one I know I'm going to get right. I'm also going to make sure I'm closed at 0. Number 2 is actually where I suggest you guys always start. Start at the f ofs, because those are dots on the graph and you can't screw them up. I call them anchors, right? F of 1 has to be 3. So the y value at 1 has to be 3. Close dot, done. Which is also the same as f of 2, close dot, at 3. That one I just got right for sure. Now, when I go read this, I have to understand what this is telling me. I will not lift my pencil anywhere on my journey except where? 2. Yep. So I'm not going to draw my graph right now, but in my head I'm going, I'm only going to lift my pencil at 2. Are we good? So the next number 4 says, as I approach 2, from which direction? Both. Excellent. From both, I better arrive at 1. Well, here's what that tells me. At 2, I have to arrive at 1. Sorry, is this the... Yes. At 2, I have to arrive at 1. Why did I put an open dot? There's a good reason. There's a word up there. Do you see how it says draw function? If I did a closed dot, wouldn't I fail the vertical line test, right? So I did an open dot there. I know I need to hit that dot when I come in from the left and from the right. So here's what I would do. I do a little this and a little that. I'm making sure that happens, but I'm going to read the rest of the problem before I willy-nilly go draw anything. So I'm approaching 1 from both directions. There's nothing else about what happens at 0. So I better sail through this dot and end up, I don't know, that'll do it. I've now pretty sure I'm going to, do you see what I'm doing? I'm just going to piecing it together. That's not the only option. But I did have to go through this point because it said the only discontinuity was here. On the other side, I've done this, I've done this. I'm going to make sure I don't lift my pencil again. I hit 1 from both directions. It's only this guy I've got to make sure that happens before I finish off at my asymptote, correct? What does it mean when it says f of x, also known as y, has exactly 2 zeros? What's a 0? Give me another name. Y can only be 0 if you do what? There's another name for it. The zeros are also called the what on the graph? X-intercepts. Yes, exactly, Abby. So I just need to make sure that I hit the x-axis exactly twice. X-intercepts, that's where y would be a 0. So maybe I'll erase this, or I could swoop down, but it's looking, I think I'm going to go like that. 1, 2, there. Did I meet all the criteria? Yes. Is it the only graph possible? No. They're pain to correct, so I only test you that you can draw one of them. So I put all of the criteria in one graph because I don't want to grade more than one graph. Do you know why they'd be a pain for me to correct? Everybody in this row is probably going to have a different graph. Probably 4 of them will have a right graph, and then the ones I have wrong, I have to figure out which criteria they missed. So they're pain to grade. All right, so that's from yesterday. Today we're going to go on, and we're going to take an algebraic approach. It's nice. The algebraic approach is... For sure, this is what happens. You're not kind of guessing off a table. You're not having to deal with a graph that may or may not show the whole because you did it on your calculator. This is for sure where the limit is. So I got to show you how to do this with algebra. First of all, we're going to do this column first over here. When I approach from the left and the right of 0 on this graph, you'll notice from the left and from the right, when I approach 0, I arrive at the same place, and I arrive at -2. So from yesterday, if that was on your worksheet, you would have used a graphical analysis and said I'm at -2. But today we're going to take the graph away. So watch what happens when I just plug a 0 in here. I get a half of 4, 0 plus 4 in absolute value bars, minus 4. I got a -2. Just plugging it in, I got the exact same answer. You might say, how is she going to give us notes for the rest of the hour that go into tonight if I just plug it in? What's the answer? You should kind of anticipate. Do you think that's all you do? For some functions, that's all you do, and those will be your favorite, and they will happen sometimes. And on your worksheet, there's some that you will just be able to plug it in, but not all the time. So when I approach 2 from the right, so let's approach 2 from the right. So I'm coming in this way. I am down at -4 according to the graph. Well, let's plug a 2 in and see what we get. We'd have a half of 0 in absolute value bars, right? Because it'd be -4 plus 4 minus 4. Well, it worked again. There's a reason why. We can just plug it in though. Okay, the last one, what do you think I'm going to do with the 10? I can't see the graph, and I don't want to regraph it and screenshot it for you, right? What do you think I'm going to do with the 10? Plug it in. Yep, I'm just going to say 1/2 of absolute value of -20 plus 4, -16 minus 4. What's that going to be? 8 minus 4, right? It'll be at 4. Had I graphed it, what do you think it would sail through at 10? 4. Notice it doesn't matter the approach either. This said 2 from the right, but I still just able to plug it in because 2 from the right is the same as 2 from the left, is the same as just plain old 2 for that function. But it's because of this type of function. It meets the criteria that it's allowed for just plugging it in. It says the function has to be continuous there. Is the absolute value function continuous everywhere? Yeah, so not even just at my approaches, it's continuous for all real numbers. Basically, I call this it has no issues. And if it has no issues, meaning holes or asymptotes, right, you can just plug it in. So it says, how can it be found analytically? Plug A in. So I'm not going to go through 6 of them plugging in, chugging. I call this plug and chug. You always start this way, though. You always plug it in. You go like this and just hope you get a nice number, right? So are you ready? When I plug in a 3 up here, I get 17. When I plug in a 3 on the bottom, I get 6. That's my answer. I'm done. We love it when that happens. What does that mean, though, on the graph? Because I took the graph away. I really want you to understand what 17.6 means. Had there been a graph, what does that mean? Andy, do you know? I got an answer, 17.6 for my limit. And it was easy. I just plugged it in. But it's super important that you understand what that means. What does it mean? Somebody's whispering in front of me. What does it mean? Super important. From yesterday, what was your limit? It's the what? I couldn't hear you. What? Sure. From both sides of 3, right? But what? Is it an x or a y value? It's the y value of the point that I arrive at, right? When I approach 3 from which direction? Both for this problem, but if I just put a plus in, it's the same answer. Because if a function is continuous and defined and has no issues, then at that spot, the left and the right will always be the same place. Agreed? So it doesn't matter whether I do a right, a left, or from both. I will arrive at 17.6, so at close to 3 on my y-axis. There will be a dot there, and it will be solid, and I will be there. Does that make sense? So let's go do the sine function. Is the sine function a nice continuous function? Not only at pi halves, but everywhere. Agreed? So what do you think I'll just do with the pi over 2? I'll plug her in. And this would be the limit of sine of 2 times pi halves. This is sine of pi. You better know what that is. You don't want to choke on the trig ones because you don't know your unit circle. They'll be nice. What's sine of pi, Dr. Bray? 100% sure. No. See, that's what I mean. It happens every year. But that's why that unit circle, you be 100% sure because you don't want to get your calculus wrong, right? Because you can't finish it off. So 100% sure, what is the sine, the y value at pi? That's my answer, right? Last one up, we'll just stick to the right-hand side. The log functions always look like this. They're like the exponential ones, but they're flipped over the line y equals x. So they look like this. They're nice everywhere, not just at 9. The log functions look like this. They're awesome. I want to approach 9 from both directions without seeing the graph. So I'm telling you, just plug a 9 in because it's a nice function. And I would get log base 8 of 2. If you know it, awesome. If you don't, have an algebra 2 way to get it. Anyone know the answer to that? It means 8 to what power is 2? 1/3. So if Zach knows it's 1/3 and he's 100% sure that it's a 1/3, write 1/3 down. But Zach, what does that mean on the graph? Because I now took the graph away and you're like, this is easy, I like this, right? I just plug it in. But what does it mean? You got a third. Do you know, Zach? It's the y value of this point that I got to when I approached 9 from both directions. I ended up at 9 comma 1/3, and it's continuous there, and I'm good, right? That's my answer. We love that. Now suppose, though, what's your name again? You. I'm looking at you right now. No. No. Yes. What's your name? No. Ryan. Ryan Wilson, right? See, I knew that. Suppose you just say, like, I don't know where the third's coming from. You should know that logarithms are exponents. You should know that it's asking you 8 to what power is 2. Maybe you hopefully remember from Algebra 2 that you have to write both with a common base. So you say, well, that's 2 to the third to the x, and this is 2 to the first. And once the bases are the same, whatever you need to do to get there, but I don't teach that, right? That's like a prereq. So I'm glad that Zach just said a third, right? Glad you knew it was the y value. That's the calculus part. But again, we don't want the calculus to fail because you can't. Do you see all the algebra I'm talking about? Algebra finishes everything. The good thing is it's usually not difficult algebra, which is nice. It's not the hard stuff from pre-calc that finishes everything. It's the meat of Algebra 2 that finishes our stuff. So Algebra 2 has got to be in your pocket. All right. And I don't think it was anyone in this class, but, well, I'm not. Let's go take a look. So we're going to analytically with algebra. Well, what happens if there is an issue? If it's not continuous and or not defined, then what do I do? Well, there's two types. There's actually what I call two types of issues on these kinds of graphs. There's holes in the graph. Those are issues. And there's what else, do you think? Asymptotes, vertical asymptotes are big issues as well. But you can't see the graph. Like this one's graphed over here, but I can't see it. So what I do is I still plug the -3 in, and it'll tell me which I've done. A hole or an asymptote will follow it with the numbers. So I plug the -3 in my head, and I'm not putting equals down. I'm just going to do a 9 and then a -12 plus 3, and I do have a 0 on the top of that one. If I get a 7 on the bottom, my answer is 0. What is 0 divided by 7? 0, it's a number. What if I get 7 over 0? Issue. And if I get 0 over 0, huge issue. Okay, so I go plug the -3 in on the bottom, and I get a 9 minus 6, which is 3, and then minus 3. This is where you go, crap. All right, this is where you learned one method in pre-calc, and I'll give you the rest in these notes. Okay, so let's see if you remember what they said to do in pre-calc when you had that issue. What did they say to do when you have that issue? Anyone remember? How do you figure it out? Like, say a word. Rhymes with tractor. Yes. What this means is if -3 caused a problem not only on the top, but it also caused a 0 on the bottom, which is a huge issue, it means there must have been an x plus 3 in both locations. Do you get why? The only factor that -3 can cause to be 0 is an x plus 3, or a factor of it, like a 2x plus 6. But there's an x plus 3 living on the bottom and an x plus 3 living on the top. We're going to scoot down and deal with that right here. So we're going to kind of piece this page together. But it says, how do you find them analytically? How do you figure it out? Well, the first thing you're going to do is factor. All right, so I'm going to go to this same one that we just plugged in the -3, and I'm writing the 0 over 0 off to the side, and I'll tell you why. And I'm going to factor it. But you have to write the limit. You can't drop it or you lose notation points. So you keep it in your work and you write x plus 1. There's the x plus 3 I knew had to be there. Understand why I knew it had to be there? Negative 3 caused the top to be 0. X plus 3 must be a factor. If you approach 5 and it causes a 0 on the top, what's living on the top? X minus 5, right? You know it. If you approach and get a 0, regardless of what it looks like, which seems weird, I'm going to make sure you're listening. I feel like I'm getting good eye contact. Don't turn the page, but I'm going to show you one we're going to be doing here in a little bit. Where was it? I think it's down. Nope. We'll find it. I think it's on this page. Right here. When I put in don't turn your notes, but just so you know what I'm talking about. When I put in a 3 on this one, I get root 4, which is 2. I get a 0 on the top, and I get a 0 on the bottom. It means that not only is there an x minus 3 on the bottom, where else is there one? On the top, you might say, nah, there will be, and it's our job to find it. So it actually will get more complicated. But you know if it makes it 0, x plus or minus, depending on which one it was, is living there, and it's your job to find it. So one technique, were you taught this in pre-calc? I think maybe, yes. One technique, and it's the only one I think you learn in pre-calc, but it's good because it gives us a heads up, is you factor first. So you're going to go x plus 3 on this one, and then x minus 1 there. These are totally equal. Wouldn't you agree? Then what are you going to do? What do you think next bullet's going to say? Why did I factor it? So I can cancel. Yep, your guys are right. So I can cancel it off. So I can cancel. And I would say that these two functions, and again, I still keep my limit. I'm going to now have the limit as x approaches negative 3 of x plus 1 over x minus 1. Now what do you think I'm going to tell you to do? You just removed the thing causing the 0. So what do you think I'm going to tell you to do now? Plug it in again. Exactly. So we are going to replug or resubstitute. So I go take this negative 3 and I put it in again. And now I can drop my limit after I plug it in and get something valid. My something valid will be a negative 2 over negative 4, which is 1/2. But I really want to make sure you understand what that means. All right, so this is the most important thing because finding the half was easy, correct? But that's not going to be your task all the time. AP will sometimes phrase it as, what value could be assigned to y so that the function is continuous? And kids will go, I don't know. Right? Because I didn't phrase it as a limit. I didn't write the word limit. But if it was this one and it said, what value could be assigned to y so that at negative 3 the function's continuous? You need to understand that all this algebra goes with the graph. This graph has a huge issue at 1, which isn't what I'm approaching, but know what it is. What's the issue at 1? There's a what? Asymptote, because it didn't cancel. It has an issue at negative 3 as well. Issues are always from the denominator. What did I just say? And I don't like the word issue, so I'm telling you, giving you a little bit more behind that, but your brain should think, where are my issues? At 1, asymptote, but that's not this problem, right? But from negative 3, I know there's a hole in the graph. Agreed? What does this 1/2 mean? I got 1/2. What does it mean on the graph? It's the y value of the hole. So although I don't have a graphing calculator and I can't go look at it, but I can actually see it up here because LaRude's got it screenshot in here, it's the y value of the hole in the graph. This right here goes right here. So the limit's 1/2 because we're there. Agreed? So if the question was phrased, what value could be assigned to y to remove the discontinuity? What's the only y value there that would plug that hole in? If I said f of negative 3 equals what? 1/2. It's the same question. But if you don't understand it and you're just like, I plug, I cancel, and the question gets phrased differently and you don't have a good visual, that's why they have to be married, the graphical and the analytical. Because Sebastian might be great at all this algebra and come up with 1/2 if it had been that question. But if it had said what value could be assigned to y to remove the discontinuity at -3, he'd be going, oh, what are they asking me to do? And you're going to say, find where the hole is so I can plug it up with its y value. Does that make sense, Jordan? So even though the math is easy, understanding what you're doing can be a little bit more complicated. Let's go to the next page. Based on our knowledge from pre-calculus, we know that a rational function, again, that's a polynomial, I call it p of x, over another polynomial, has a discontinuity that can't be removed. That one I could remove. All I'd have to do is say, you know what, Maya, let's just let f of -3 equal a half. And she'd be like, okay, that'll just plug that hole up. I can sail right on through. Sometimes we call it building a bridge. But if it's non-removable, there's two options. You either are split, and there's no way I can just plug that gap, or this says infinite. What do you think that means? If you can't, that's asymptote. Yes, what kind? Vertical. Yep, that's code language for vertical asymptote. And then here, let's write VA. All right, so here's the deal. We like this better than the 0 over 0. Because there's only 3 options for your answer. When you know you have asymptotic behavior, and you might say, how will I know that? I'll show you. So Abby goes and does what LaRude says. I say, you always plug it in. Always, whether left, right, both plug her in, right? When I plug it in on the top here, I actually get an 8. When I plug it in on the bottom, I get 3, I get a 0. That tells me I have an issue, but it's not the hole in the graph. Because I didn't get, think 0 over 0, like 2 holes in the graph. What's the answer to 8 divided by 0? You've been taught that it's what? Undefined. We might want to refine that a little bit. Because when you do division, you're telling me how many 2's add up to 6 and how many times you could add them until you reach 6. So really I'm asking how many zeros would I have to add up to reach 8? And we'd start. We go 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0. What's the answer? How many of them will I say? An infinite amount. So really what this tells me infinities. All right? Does that make sense? Which means if my limit's infinity, I'm at an asymptote. So do you get why you have an asymptote there? The problem is, how do I know whether it's infinity, negative infinity, or what I call a true DNE? This is your 3 choices. Anytime you get a number over 0, you only have one of 3 choices. And actually for this one of them's out. Which one do you think it's not going to be based on my approach? What do you think? D and E. Because we said yesterday, if it goes up, what are you going to put? Infinity, which doesn't exist, but it's called a refinement of your answer. If it goes down, what are you going to put? Negative infinity. If it's a 2-sided approach and both go up, what are you going to put? Infinity. If it's a 2-sided approach and both go down, what are you going to put? Negative infinity. What's the only time we put D and E? 2-sided approach and boom, opposite. Awesome. So how do I decide? So Abby plugs it in and she should immediately go one-sided. My answer is infinity or negative infinity. Everything else is off my plate. So if you didn't know, at least you would guess, right? This is what I call become a creeper. You are now going to marry. We're talking now about the graph when you can't see it. We're doing it with algebra, right? We're not making the graph, but I'm now going to marry the creeper. I'm going to pretend I was making a table, but I'm only going to make a very, very tiny small part of it. Okay? All I want to know is what happens right to the left of 1. There's a 0.9 here, but I like to add a few more because I like to get it into your head that we're going to be so close. And all I really care about is what the sign is. That's all I care about. I don't care about the answer, so we don't need a calculator. We just go to our simplified expression, because we already cleaned this up on the previous page. We just go to what we simplified, and we just do a sign analysis. If I was coming in from the left, this would have been positive. I don't care what it is. What's 0.999 minus 1? Negative, that tells me. From the left, what's my answer? This would imply my answer is negative infinity, which doesn't exist, but don't write D and E. All right, now if I was coming in from the right, then I go and I make a table, I creep in but at just one number, super close to the, you don't have to make the big tables from yesterday. You'll never do that again, to be honest. We're just going to kind of be a little creeper here, and we're walking up as if we could see the function. Where would it be? Would it be going up or down? I'd have a positive on the top and then a positive on the bottom. By the way, my top would be, let's do, I actually like 1.0001. I don't know why I put the 1 once. That's actually farther away. But anyway, watch what this would actually do. On the top, it'd be pretty close to 2, wouldn't you agree? Do you agree that the top would be pretty close to 2.0001? But for all shits and giggles, it's a 2. On the bottom, I'd have a 0.0001. What is that? 1 over what? 1 over what? Go ahead and tell me. What is this decimal? 1. Oh, I'm going to take off the stuff that I said. It's pretty darn close to 2, just so you can see what I'm talking about. 1 over 10,000, right? And when we divide by a fraction, we multiply by a reciprocal. Don't you agree with me that that would be 2 times 10,000? About 20,000. Is that going way up or way down? Way up. Again, we don't really care that it's 20,000. This plus over plus tells us it's shooting way up, but I wanted you to see why it's shooting way up, right? That's going to be so tiny on the bottom. When we multiply by a reciprocal, it's going to blow up. So this is going to infinity. Now, how could I change the original function? Let's do this one. What's one minor change I could make? Maybe I'm writing a test and I put that one on there and like, oh wait, I just did one like that last time. I want one that comes out to be D and E. I wouldn't delete the whole problem on my Google Doc, right? I'd go into my equation editor and I'd delete one thing. And it'd totally change the answer, right? What would the one thing I delete be? The plus sign. Yep, because then Emily would say, oh, I got to come in from both directions. And she would actually have to do 2 creeps. She'd have to creep twice. She's creeping in from the left, heading down, creeping in from the right, heading up, and then she writes her answer. And then it'd be what? Does not exist. So do we get the difference between? All right. So let's move right along here. Now, I showed you this one at the beginning, and you can see the graph over there. You won't be graphing, though. I use it in your notes so you can actually see your analytics, your algebra, confirmed with a graph, but you can't make the graph. When you're in your groups tomorrow, I'll say everybody's calculator's out. And on your test, will you have a calculator? No. So you can't rely on the graph, but I like you to see it. Does that make sense? So let's go take a look at this. Sean plugs it in. He gets 0 over 0. He goes, crap. But he should know some stuff. 0 over 0 is an issue. What is the issue? A hole in the graph. But it's right? That's the only issue for a rational function. It's going to be a hole in the graph. We need to figure out where we are. He might say you factor. I'd say certainly if it was factorable. But he actually also, we talked about this, because it's causing a 0 on the top, who's actually up there? X minus 3 is living there. You have to find it. And the way you find it when you have the roots is you do rationalization, which means get rid of the root. And you've rationalized the denominator before. What would you multiply top and bottom by to rationalize that denominator? Another root. Agreed? So we deal with the root, whether it's on top or bottom, it doesn't matter. It's the root you focus on. And you multiply the top and the bottom by its conjugate. So we got to talk about that word. I know you know what it is, but what would be the conjugate of? And again, it's the one with the root in it, because we're going to get rid of that. Because I told you, I want to see an x minus 3 up there. Well, I better get the root off, right? What's the conjugate? Do you remember? Oh, dang it. Yes, and you had the highest score in the test. Why can't I remember your name? He aced it. And I knew it, and your face was in my brain, but every time I look at you, I go, whew. All right, Noah, Paulson. See? It's there. All right. Anyway, what's the conjugate of the top? Do you remember that vocabulary word? Perfect. You keep the front, you keep the back, you change the link. You do the bottom by the same thing, or if the root had been on the bottom, you do the top. All right. Now, why will the blue stuff not disrupt the integrity of the problem? it will be the exact same thing with what I call a facelift. Why is that blue stuff totally legal? Because I can't just choose to do whatever I want. I got to make sure I don't change it. What is it? The blue stuff's just 1. So you multiply by 1, you get the same thing. But what it does is it helps me find that x minus 3. So, oh, bless you, sweetheart. All right, so wherever the conjugate is, or the root factor is, you're going to FOIL. You'll leave the other level alone. Notice I didn't say the denominator because maybe your root was originally in the denominator. Okay, your goal is to get rid of the original root. So you're going to FOIL. And when you have conjugates, I'm sure Noah knows, but you don't really need to FOIL. You just need to FOOL, right? Because what happens to the oi? Always with conjugates, they're beautiful that way. So you just need to do firsts, and that's why this works, because a root times a root will cancel out. We'll just get x plus 1. And then when I do my lasts, I just get minus 4. Well, what did I just find? I found the x minus 3 without changing the integrity of the original function. On the bottom, don't FOIL it, because you're going to want to plug this in. And it's going to be really ugly to plug into a whole bunch of stuff. So we're just going to leave it on the bottom. My goal was to find the x minus 3. I found it. Don't mess with the other level. So we're going to go like that. Now that I've found the issue, and it's on the top and the bottom, there's a hole. What do I do with the issue in this scenario? Cancel it off. So I'm not going to rewrite that as x minus 3. I'm fine with you going like this and going like this. Now what will you do? Plug it in. So I'm going to plug this in. I'll get 1 over root 4 plus 2, 1 over 2 plus 2, a fourth. What does that 1/4 mean? It's the y value of the location of the hole. Agreed? If it was a continuity question, I said, what value could I assign to f of 3, or f of 3? So that the function is continuous. You would just write f of 3 equals what? F of 3 equals what? 1/4. Why? So that I could fill in the hole that's there. It would look like a piecewise function. I'd say it's this everywhere, and then at 3, it'd be a fourth. All right? So moving right along. Here we go. We're not going to do the piecewise because we've talked about that enough where we shouldn't have to. That's why I did piecewise early, so you had a good concept of them. So we should be able to just move to this page. So first up, I am supposed to take the limit as x approaches -2 from the left. Which piece of the piecewise will that be, top or bottom? The left of 2. Will that throw me into the top or throw me into the bottom piece? You got to use the inequalities. Which one will send you to the left of -2? Top piece. Yep. So what that's telling me is this actually is when I'm approaching -2 from the left. This will be used when I'm approaching -2 from the right. What about at -2 for this problem? It's what? Undefined. Does that mean the limit doesn't exist? Can I just bail for part C and go, doesn't exist? There's no dot there. But guess what has to happen from the left and from the right for me to not? This is a great question. What's going to anticipate, right? What's going to have to happen for part A coming in from the left and part B coming in from the right for me not to write D and E? Same. It's going to have to be the same number, right? Because we have to end up in that parking lot, right? Even though it doesn't exist there. Jimmy John's is gone. -2 is not there. Agreed? So we have to make sure that we're coming in at the same. So all you do is plug it in. You just go up here and say I'm going to do 2 times -2 squared plus 3 times -2. You do a little arithmetic. 8, 6, -2. Watch my arithmetic. I'm trying to go fast because I want to get to a certain spot. Am I good? When I come in from the right, that's going to send me to the bottom function because to the right of -2 is bigger. So I'd have -1/2 times -2 plus 1. 1 plus 1 is 2. I'm at 2 from both directions, but 2 doesn't exist. What is there on the graph there? A hole, not a gap. Not a jump, but a hole. So what's the limit? 2. All right, now suppose, are you ready? So suppose you had plugged it in here and got a 3. What does that mean on the graph? One's at 2, one's at 3, right? There's a little hiccup. So what would my answer be? D and E. You're close. What restaurant's close to Jimmy John's in town here? But you're not finding each other, right? I don't know what restaurant's close, but you have to be at the exact same place. All right, let's go practice. I want to get to certain spots. We're going to cruise. Are you ready? What do we do first no matter what? So your worksheet tomorrow is going to have a whole bunch of analytical limits. First thing you're going to do is plug it in. If you don't get an issue, what are the issues? 0 where? Bottom. Be it cancel or not, and we'll cover both. But when I plug this in, I get ln E over 2e. Ln E is what from your test? Most of you got it. It's 1. 1 over 2e is valid. The natural log function is continuous everywhere. 2x is a line. It's continuous everywhere. We're good. We have no issue at E. Agreed? Done. That's my answer. Let's go to letter C. So I'm approaching pi. What am I going to do? Go ahead, tell me. Plug it in. And there's no way I'm going to get an issue because there isn't even a denominator, right? So the denominator can't be 0 anywhere when there isn't a denominator. But if one of those was tangent, beware. All right, but I'm going to just plug it in. This would be sine squared pi. Sine squared pi plus 2 cosine pi. Agreed? Now make sure you know your unit circle. Do you see why I had to make unit circles in every section? 100% sure what's sine of pi? Yes, you'll never make that mistake again. And when I square 0, I get 0. 100% sure, Mr. Bray, what's cosine of pi? Perfect. So he goes 2 times -1. He gets a nice number. That's his limit. And, Mr. Bray, if this had been a positive, I'd still be there. Because it's a nice you know what I mean? It doesn't matter. I'm coming in from the left. I'm coming in from the right. It's continuous. There's not an issue. There's not a hole. There's not a, you see what I mean? So it doesn't matter. Then years past that as bug kids, they'd say, well, what if I'm coming in from the left? I'm like, plug it in, right? So we're going to skip down to, actually, yeah, I might do this one in the notes. I'm going to remind myself, but the video notes. Let's go to letter E. What are you going to do? Okay, go ahead and plug it in. I'm going to tell you what not to do after you plug it in. So you go plug it in, and you should actually plug them all in. Because if you get a number to your answer, if there's an issue you want to know, is it an asymptote or a hole in the graph? Okay, so this one's going to be a hole in the graph. Why'd you say that, Gus? Okay, so he got 0 over 0 when he plugged it in. Did all of you? What are we going to do when it's a polynomial over a polynomial? What's our attack? I got to figure it out. I know there's an issue. We're going to factor. What factor do I know is living on the top and the bottom? Yeah, it really helps when they get icky to factor. But these are, I mean, these are so easy to factor, probably not helpful. But sometimes, like when you lead with like a 3 and you're like, oh, I got to do that. If you know x plus 2 is one of them, it certainly lets the other one fall out without as much brain power, right? So I know for sure there's an x plus 2 on both. So I'm just even going to go put that on there. And then if they were hard to factor, I know at least I'm sucking an x plus 2 out, right? This would be a 2. And then this one be an x minus 3. Now, right here, you're going to lose points. This is what I call slop. It may get you the right answer, but I will not give you full credit. What did you do? This isn't equal to this. I have to still keep that limit until I plug it in again. All right, now I'll show you what else is illegal. All right, but it's called, there's always a notation point. So it'll say student uses proper limit notation, not if you drop it and just go start doing whatever the heck you want, and it's not me being picky. So when I go cancel, right, I will cancel this and I will cancel this. You can just, that's sufficient, right? Now what do I do with the -2? I plug it in and I get a -5. Now I can drop the limit. I get a -5 over 2. All right, are we good? So what does that mean? That's the y value on the graph. Agreed? Now watch what you can't do. If you put equal, 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 As an AP reader, if I was reading they come in from all over the world, and we sit in this room, and it's just this huge process. And we have a super detail, we get briefed for like 2 hours on how we specifically grade the problem we're reading. If this one had 3 points attached to it and it said 1, student factors correctly, would this student get the point? Yes. If it says 2, student removes the discontinuity, which is the canceling of the x plus 2. Did student do that correctly? If it says 3, student's answer. Is my answer right? Yes. But I would remove a point, because with the equals, what are you telling me 0 over 0 equals? 5/2. And it should have been a negative, right? I think I forgot it. So I'd actually have lost that answer point anyway. But because I'm saying 0 over 0, when I say what's 0 over 0, would you ever say negative 5/2? No. And that's called a linkage error, and they come off the answer. So know that. The safest thing to do for AP is leave the equals off, to be honest, because I can't dock you for linkage if you're truly not linking them. Then we call it a train of thought. Now, if Cooper does it again in the next part of the same problem, he gets what they call inoculated for it, which means I already dinged you for a linkage error. I can't do it again in that problem. So what's the most points you can lose for linkage? 1 within a problem, and they're worth 9. There'd be more to this. Like, I can't get, you know what I mean? There's 9 points, and you get 15 minutes, but I'm just giving you a heads up. I wanted to get to this one. Perfect. Because this is where I stopped last hour. So I'm going to plug the 3 in, right? I plug it in and I get 8 over 0. Notice I'm going to leave my equals off, but I'm going to show good notation. I actually like it better. You'll know why when we get to second semester, when kids go like this. It has to do with something called L'Hopital's rule, which unfortunately we don't do till April. But you're going to even want to just tell me where they're going. So if you want to start that early and just say, oh, this is going to 8 into 0. Now stop. What does that mean graphically? What's happening at 3? Asymptote. I'm now down to 3 answer possibilities. I had to turn and look. You should know why, because I wasn't sure if I was going to say 2 or 3. Are you in my head? Did you see me turn? I said we're now down to 3 possibilities. Why didn't I say 2? What was I looking at? Yes, I was looking at the approach because I didn't look carefully. I'm approaching from both directions. So my answer could be infinity or negative infinity or D and E. In order to figure it out, I have to creep. I'm going to tell you it's easiest to creep if you factor first. So I'd always suggest factoring, even though nothing's going to cancel. It's helpful for you to do sign analysis. From which direction must I creep? Notice I didn't put my preposition at the end of my sentence. Anyway, see, you learn more than math in here. From which direction should I creep, Juice? Maybe creeper. I don't know. I can't graph it. Both sides. So let's go in from the left first. If you want to make a tiny little chart, you can, but I'm fine. I'll know that you're coming in from the left if you go 2.99 or 999. You need to plug it in and do a sign analysis. I don't care where you're going. I just want to know up or down. Top, positive. How about the bottom? Positive times a negative would be a negative. I'm going to negative infinity from the left. Then you said both directions, Juice, so what should I pick from the right? It's like making a table yesterday. We don't pick directly to the right. We're not going to pick 10, right? We want to get really close. What are we going to pick? Yes, and you're going to get positive over positive. What's your answer going to be? D and E. What's your homework? Finish notes. I'll try to keep them as short as possible. Those of you who come in with notes done, we'll get in groups and do the assignment in class. All right, have a good one. You guys are awesome. Sorry about the long notes.